Okay, so
thank you, Fabian.
Okay, thank you. All right, so this is example 8. Okay, so what is example 8 all about? So you have a want to suppose that this is the length of diagonal of rectangles. So rectangle here, so you know rectangle how it look like. So this rectangle. Okay, rectangle have two sides. The longer side is called length, x here. The shorter side is called y. So diagonal is called d. So up to you what which one diagonal. There are two diagonal there. So this is d here. So this right rectangle is right angle, right? So that means that I know where is d square now. Now they want to find the rate of change formula now. Okay. So this question about rate of change formula. Find a formula for rate of change of d. What is it? Respect to x. If x remains, where y constant. Okay, so what is actually means? Okay, the one I highlighted. Find the formula for rate of change of d with respect to x. So what they are looking for is partial differentiation of d with respect to x now. Okay, why is it partial differentiation? Because d depends on x and y. Okay, so when x change, you can find the partial rate of change of d with respect to x. If y change, then you can find the rate of change of d with respect to y. But always keep the other constant, right? If you find the rate of change with respect to x, you always keep y constant. Okay, so this is what they want now. This is what I mean by rate of change of d with respect to x, while y is held constant. So how do you do that? So there are many ways to do that. You can first simplify d first. D is equal to square root, right? Or I can differentiate d directly. So that means I just differentiate directly with respect to d squared now. This is one way. Okay, because another way is that d equals square root of x squared or y squared. Then you have power of x squared by y squared now, square root power. So makes things a bit difficult here. So I can do this. Okay, let me later on I show you how. If you want to differentiate with respect to square root, okay. So because now differentiate with respect to d squared, you get what? Get 2d. Partial differentiation of d with respect to x here. Chain rule. Normal chain rule, just like that. Then differentiate x squared, you get 2x. And differentiate y squared because y is a constant, so you get 0. So partial differentiation of d with respect to x is actually x over d. Okay, so we know this is x over d now. And what is d now? Because d is equal to square root of x squared by y squared. When x equal to 3, y equal to 4. So this is 5. So partial differentiation of x d with respect to x here, when y is fixed there, is x over d. Okay, so this is x over d now. X over d where x is equal to 3, y equal to 5. So 0.6 there. So this is d is in terms of maybe in cm. So this is cm. Right? Actually, not really in cm, just rate of change only. Okay. So what does it mean now? So whenever x is increased by 1 cm, okay, whenever x is increased by 1 cm, then the diagonal will increase by 0.6 cm. Okay, so the diagonal increase at a rate of 0.6 cm whenever the x is increased by 1 cm. Okay, this is what it means, right? So you can find this, this ratio here. So this is actually how to interpret partial derivative, right? So let me say something about what happens if you differentiate directly. Another way to do this, so let me insert a new page here. So you can find just now that d equal to square root of x squared by y squared, right? So you can also do directly partial differentiation with respect to x here. So this is actually
Mr. Quack, this is like
yes,
example 5.
same example. This example 5, are you sure?
Yeah.
No, this is not example 5, this is example 8, right?
I mean, as in the method you're doing now is for example 5.
Oh, the method I doing this is for example 5. This is example 5, I do it directly, is it? Okay. Okay, example 5, I do it directly. Okay, fine. Okay, so let me see. Okay, so this is, instead of doing d squared, then you can compare a difference. So this is even half, then x squared plus y squared minus half, then differentiate the inside, x squared plus y squared. So you get half square root of x squared plus y squared, and then this is actually 2x. Okay, because y is 0 now, y is constant now, so you get x over x squared plus y squared, which is actually x over d lah. So it's the same answer. Okay, just show you that you can actually do this same answer. So example 5, example 8, look at this. So this is example 8. Show different method, right? Just now I just differentiate directly. Okay, just now I just differentiate directly. Okay, differentiate directly d squared. Okay, you can actually do this. You compare the method. Okay, all right. Anyone got issue there? So if no, then I'm going to continue to apply the implicit differentiation example 9. Okay, so I think this one will be some maybe I need more space. So let me insert more space first. I think I need more space. Okay, so this is fine. Okay, there's an issue with this problem here because unlike the previous one, so this expression got x, y, and z, right? So normally we have a z as a function of x and y. Then you differentiate directly. And then you say, oh, partial differentiation with respect to x and partial differentiation of z with respect to y, right? You differentiate directly. Okay?
Okay.
But in this example 9, why we cannot do this now? Because we cannot find, but now we cannot find, okay, explicit formula for z now. Z equal to f of x and y. Z depend on x and y only. Okay, why is it so? Because you look at this equation, I have this exy sin z. Okay, there's a z there. Then plus yz equal 0. So how do you arrange so that you make z the subject now? So this one impossible, right? Impossible, no? Okay, you have sin z. And how do you make z the subject now? So because you cannot make z the subject, because they are trying, okay, rearrange the thing so that make z alone appear on one side only. Then you, but then you find that this is not cannot be done. So therefore, you can only do the differentiation implicit now. Implicit now. Okay, so you don't differentiate the dz dx directly, the implicit term. Okay, so what doesn't mean implicit term? Just differentiate term by term first. All right. So this one will be a bit long-winded here. So differentiate by respect to x first. I want to find x, right? So the exy sine z plus differentiate by respect to x here, yz. Then right side is 0 anyway. Okay, when you do differentiation with respect to x, remember your 3y constant, all right? So that means that 3y constant. Y is a constant now. Okay, now remember z is a function dependent on x and y, no? Z is function, although I don't know what does it look like, but this is a function dependent on x and y. So now I'm going to use the product rule here. So because this is a product of two terms, which involving x here, so function, okay, so function of z depend on x, right? So you have to do product rule now. Okay, because z depend on x. Okay, so z depend on x. When x change, z will also change. Of course, exy will depend on x also. So need the product rule here. So the first term will differentiate, product rule. Let me write down product rule here. So how to product rule? So differentiate u and v. Product is u dv dx plus v du dx. This is product rule.
Yes.
All right. So I'm using the product rule now. So you will keep the first term exy. Differentiate the second term with respect to z. Okay. Then keep the second term. Differentiate the first term with respect to x here, exy. Okay. Then because now y is a constant, because the y fixed now, so y is a constant, so take out, you only have differentiate with respect to x now. Okay. So this is after you differentiate one. First time you using product rule, second term differentiate, pull out a y because y is constant now. So what is differentiation of sine z now? So we all know that differentiation of sine z is cosine z. Okay, but then you don't stop here, you must differentiate z again, right? It's called chain rule. Okay, differentiate z with respect to x. This is called chain rule, right? This apply the chain rule. Okay, so this is the chain rule here now. Then the second term, sine z. Differentiate with respect to x here. The y is constant now. So okay, y exy, right? Differentiate y. You differentiate exy, your y is constant now. You get exy, then differentiate xy with respect to x, you get y. Okay, then y dz dx. Okay, so I'm going to find out what is partial differentiation of z with respect to x now. So I need another page here. So I'm going to copy this in. Okay, I did copy now. So next page there, I may need another page. Not sure whether I need another page. Never mind, just work out first. So now I collect first, all right? So where are the collection? So the term are here and here. So what you get, combine them, you get exy cosine z plus y or dz dx is equal to negative outside z, y, e, x, y. Okay, so bring it the other side. Okay, there's a negative sign. So the dz dx here is actually minus sine z, y, e, x, y over e, x, y cosine z plus y. Okay, this is how you get the dz dx here. This is implicit differentiation. So that in the answer, you still find z inside the answer. Then z is still appear in the answer. So this is called implicit differentiation. Okay, so let's try to find respect to y now. So our expression is exy sine z plus yz equal 0. Okay, I want to find the partial differentiation now with respect to y. So we get exy sine z, and the other one also differentiate with respect to y. So this one is slightly harder now. Why? Because y appear in both terms. So you have to use product rule, keep the first term, differentiate the second term. Okay, then keep the second term, differentiate first term. Then there's yz now. Both of them are y now. So y keep the first term, differentiate second term. Then keep the second term, differentiate first term. Then is 0. So again, this exy, differentiate sine and cosine. Then partial differentiation with respect to y. Then exy with respect to y now, you get x sine z e x y, right? Then this one is y dz dy plus z equal to 0 now. Differentiate with respect to y equal 1. Okay, so I need to copy this thing. Continue. Okay, I did. Copy. Go to the next page. So you look like this, something like this. So you look at where is your dz dy. So dz dy are here and here. Collect them. Get exy cosine z plus y dz dy now. On the other side, you have this, move to the right hand side, then move to the right hand side. So you get minus z now, minus z minus x sine z of exy, so that you get partial differentiation of z with respect to y, and minus z minus x sine z here, exy over exy cosine z plus y. Okay, so this is how to do example 9. Okay, so this is still mechanical work, right? Just show you how to do implicit differentiation. When you do implicit differentiation, because you cannot get exactly the formula for z now, and therefore you have to try the implicit differentiation. Okay, so any issue with this one? Okay.
But then normally during like exam, right, they'll ask you to like simplify the thing one. Then how do I do it?
This one, what do you do? There's actually you cannot simplify anything, right?
Okay.
This one you cannot simplify anything here, because I don't think you anything can simplify here. Okay.
Okay, thank you.
Okay. All right. So there is example 9. Right. Example 8 very easy. As well, example 9 I think a bit complicated because you use the product rule, chain rule, right? Or product rule, chain rule, everything that you come across and use it now. Okay. Now I go talk about higher order derivative. Okay. So this is on page 7 now. We have seen first order differentiation, which is partial d with respect to x, okay, partial d with respect to y, okay, okay, f is a function of x and y. Okay, this is the first order. Now, second order differentiation is usually first order differentiation is about rate of change. Okay, how to find when x increase by 1 meter, how do you expect f will increase, right? Same thing for if y increase by 1 cm, then what do you expect the changes in f there? So how about second order derivative? Okay, second order partial derivative, right? So we have a notation here. So if you differentiate x one time, and then you differentiate again with respect to x here, okay, we have a name for this. Notation is differentiate f with respect to x 2 times, just like normal way you write differentiation. Okay, we also call this f of xx. Okay, maybe the notation. Okay, normally, for example, this one I also call fy. This is called fx here. Self notation, right? Usually partial differentiation. Okay, let's see another one. Of course, you can talk about differentiation of respect to y. The short form will be just differentiate with respect to y to f2 time, then with respect to y squared, right? So dy dy, okay? This is a short form to write this. So this is actually fyy. Okay, the part that is confusing is what happens if do x first and y. Okay, if I differentiate with respect to x first, then with respect to y. How do you write this? So you just follow the notation. Basically, it's differentiate with respect to x first, then y. Okay, so that means that this is the first one, first, this second. So the way to write this is actually you write this as f x y. Okay, first one respect to s, first, the second. Okay, then of course you can do the other one, which is actually if I do differentiate with respect to y first, let me use a black ink. Okay, if I differentiate with respect to y first, then x, of course this is equal to d2f dx dy. Okay, so dx dy partial difference del x del y, right? So the first one, this is first is y, second is x. So you can also write it as f y x, right? I mean y is the first one, second is x. Okay, this is notation. All right, so let's this the other notation, but the common one is actually something like this. This is a common one. People remember this one, which one is x and y, which one is first one, which is second one, right? Okay, so if this is the case, I look at example 10. Okay, example 10, how to find the second order partial differentiation. Okay, so now x squared y cubed plus x4y, this is a function. Find the first derivative first. So partial differentiation with respect to x. Let's see what I do now. Can you do straight away? So what is this one? Partial differentiation with respect to x here. It is actually keep y fixed, right? So the y cubed 2x. Then keep y fixed, right? You get y take out 4x cubed. So this one I know is 2x y cubed plus 4x cubed y. Whereas if I differentiate with respect to y, I have x squared 3 y squared plus x4 1. So this is actually second one. Fy is, okay, let me change way. Just give more space a little bit here. Okay, plus 4yx cubed. So the other one is 3x squared y squared plus x4. This is the first differentiation, partial differentiation. So now I differentiate with respect to x another time. So differentiate with respect to x. So 2y cubed, right? You have 2y cubed here. Then plus 4y 3x squared. So you get 2y cubed plus 12 x squared y. Right, differentiate by respect to x 2 times. Differentiate by respect to y 2 times. Let's see what I get. Okay, so then you get 3x squared to 2y, and then 0 now. So you get 6x squared y. So these are the differentiate with respect to x 2 times, and then differentiate with respect to y 2 times. Now how about differentiate with respect to x first, then y? Okay, this is notation, and x first and y. So let's see what do we get now. So x first. So x first you get 2xy cubed, 4y x cubed, right? So differentiate by the x first, then in y. So you get 2x, then 3y squared, then 4x cubed, differentiate y, you get 1. So this is actually 6x y squared plus 4x cubed. Whereas the other one, differentiate the y first, we have 3x squared y squared plus x4. Then differentiate with respect to x and y fixed now, you get 6x y squared plus 4x cubed. Right? So this is how you do the mixed differentiation. Now I want you to observe these two ways. Usually they are equal. These two
The
same, right?
Yes.
Okay. These two are the same. So usually you expect them to be the same. Okay, unless the function is not differentiable. Okay, if the function is not differentiable, otherwise you expect most of the time they will be the same. Okay, so take note of this because a lot of time it saves you a lot of trouble. Because see the function actually is polynomial or something, you can always differentiate, and you just go ahead and do one of them, and you get the other already. How about then? How can you do the third order partial derivative, right? The pattern is the same, okay? It's the same, but you just look at, okay, on the left, basically in left side, okay? So for example, if you have a, okay, if you have this one, for example, this one differentiate x first, then y second, then y third. Okay, so basically this is how the notation is. So for example, this one differentiate x 1 time to y 2 time, all right? So okay, so you can actually, if you do that, you don't need to must follow the order, okay? It means that you don't need to differentiate x first. You can differentiate y first, then x and y, okay? And many possible way to actually get the same answer. Okay, so next example is example 12. Okay, and 12 will be a messy one. Okay, hopefully it's not too messy. Okay, so far, all right. So example 12 now. I hope example 12 at the another page, I think. Let me insert another page first.
Mr. Kwek, what about example 11?
This is example 11, right?
Oh, okay.
This is example 11. Yeah, sorry. Okay. So just now I do example 10, right? Yeah. Okay. So what is this thing? Okay, let's try interpret them correctly. So this is actually f x y y. Right? X y y. What does it mean? Basically, it means that differentiate with respect to x first, then with respect to y, then differentiate with respect to y again. Okay, this is what it means. Okay, this is one way. And then later on we compare, okay? Afterward, do you get the same answer? The other one is actually f y x y. Basically the same, you get actually differentiate with respect to y first, then x, y, then y. Okay, so I think that you need space to figure out the answer. So let's try the first one, okay? So first thing, you need differentiate with respect to x first. So you keep y constant now, so this is y squared. Differentiate ex, you get ex here. And if we differentiate y with respect to x, you get 0. And so this is y squared ex. Then differentiate with respect to x, y constant now. Okay, now let's try differentiate with respect to y now. Okay, differentiate with respect to y now. So
2y ex.
so you get 2y.
Ex.
X constant now you get 2y
Yes.
ex, right?
Yes.
Okay.
Plus.
Then finish, right?
Finish
Then you
already.
differentiate
That one is 0.
No, plus 1, plus 1.
0 lah, bro.
Eh? What 0 eh? Y what? Oh, that x.
Because your y square is a constant. You differentiate a
Oh.
constant is 0.
Trolling.
So your whole stone.
there is no product rule here, right?
No, I thought it's like differentiate to the y or something like that. Like you d f dy. I thought it's df dy.
Differentiate that. Okay, now
Yes,
let's look what.
sir.
So now
Sir.
anything. So I'm going to differentiate again, So this is differentiate
You get 2y.
2y ex, right? So you get differentiate. So ex constant,
2x.
differentiate 2y, you get 2, right? Okay, 2x.
Yes, sir.
Yes, sir.
So it's really not that difficult. I thought it's very difficult. Okay.
It's
So
a quite
this,
question.
yeah.
Okay, why not we write like fx then fxy then fxyx.
What I mean, fx. So
Like for the df dx, right, you can write fx. Right?
yeah, I mean, this is actually fx style. So this is actually this is a new way like this fx style, yeah.
Then we can make it like shorter. You see like you write like three fractions like very long. That's why you can just make it shorter by writing fxyx.
Okay lah. Okay, this is if you write this, so this is actually x y, right?
Yes,
and this
sir.
is actually f x y y. Okay.
Yes.
So just a notation here. Okay, now we're going to compare the answer, right? So next one, okay, I'm going to short form here. So you're going to first fy first. Fy, okay? Differentiate f with respect to y now. Okay, this one slightly harder. Your x is constant, so you get ex 2y, then plus 1. Okay, differentiate f with respect to y. Your ex constant, differentiate y squared, get 2y. Okay, differentiate y, get 1. So this is fy now. Now, I want to f y x. What does it mean? Okay, sometimes people get confused, so I better write down here this partial differentiation with respect to x first of fy, right? So differentiate with x, what do you get? You get 2y.
ex 2y.
Right? Yeah, ex 2y.
Plus kosong.
Kosong, right? So
Yes, kosong.
then after that, finally, I write f y x y.
Yes, sir.
So differentiate with respect to y again. You find that keep ex here.
OEX.
You have 2, right?
Yes,
Differentiate with
sir.
respect to 2, right? So you get 2ex here.
Oh, it's the same thing. Oh my
Okay,
god.
so again the same thing. Why? Because basically you're trying to tell you that differentiate x one time, y two time. You can anyhow arrange them to differentiate them. You get the same answer. Okay, as long as you want to differentiate x one time, y two time, same. Okay, so same. Okay, so that give you a summary first, right? Summary first. Okay, summary. So basically, you expect, okay, if the function is continuous, basically most of the time you don't need to worry about this unless the function behave very differently. Most of the time you get nice function, can differentiable. Okay, so you expect fxy, xyz the same. Okay, so usually you don't need to worry about this result here. Just apply it because you don't usually don't encounter very difficult function. But you need to check the function whether differentiable or not, or continuous or not. So, okay, I think everybody is here, right? So you can actually do the quiz now. So I give you 15 minutes to do a quiz. You know the quiz now. Anybody did the quiz before? Okay. I think should have.
Haven't yet. Haven't yet do. Haven't do it.
Think
Haven't do
haven't,
it.
right?
Yep, yep.
Haven't nobody do the quiz there. I think Polar one people have done.
Which quiz? Which quiz?
The quiz on not the Polar one. It's actually the
Oh, you just put up 5 MCQ
yeah the
only.
one. Okay, yeah, yeah. So you can see the let me see learning resource. Okay, I mean where is it now? This one I have.
Week 1.
Okay, I don't know what happened.
So is there any password?
Yes, there's a password, right? That's why you need password for you to check. Okay,
Password is your
password for the quiz. Okay, from now on,
Alibaba.
Okay, password. Okay, so you get 15 minutes to do the
Oh,
quiz.
your favorite word there. Okay lah, can lah.
Your favorite word lah, Yong Ping. Alibaba you.
So then 7:05, I'll start again.
Sorry, teacher.
Yes.
Is a quiz on parametric curve?
Yes, on parametric curve, not polar curve. Okay, parametric curve.
I have done it.
Yeah, you have done it already. So do you score finish perfect score?
Answer.
Because everybody don't get the same question, okay? You don't get the same question. If you get a perfect score, then you can rest already, right?
Yeah, thank you, share.
I don't think everybody got the same question, okay? There is enough question to go there.
Okay, how do I write the password? Yeah, I cannot write password there. Hello.
Capital A, the rest all small letter.
Mr. Koi, I cannot access the quiz.
Huh? Did you do the quiz before?
No. Week 2, is it?
Sorry, it's week 1.
Oh, week 1. Okay.
Week 1. Okay, week 1 there are 2 quiz, right? The one is polar curve, the width, then the other one is parametric curve.
Which one is it? The parametric curve.
Yeah, parametric curve.
Thank you.
Sorry, Mr. Quack, the parcel
Yeah.
don't work. The parcel cannot work.
Huh? Cannot move.
I cannot work. The parcel cannot work for me.
ALIBABA.
ALIBABA.
Yeah, small letter or small letter except the first letter. Okay, yeah, I thought because last time I didn't set password and then people suggest I set password because they want it to be done in class, so it's fair for everybody. Okay, so okay, fine, I agree. So fair for everybody, so everyone do in class.
So if I have done this one, then how?
Then you don't need to do like I thought. Do you get perfect score?
Yeah.
Perfect score is good. Then you don't need to rest for a while.
Then last time when I do it, it doesn't have the time limit.
Which one?
This one I sent you the chat already. Is this one?
Okay, let me. Okay, what is that? Let me check here. Okay, CRS. So, do you send it in the class? Is it or what?
I mean in the Teams. Oh wait, let me send again.
Okay, it's a team.
Yeah, I sent you the WhatsApp. I sent you the WhatsApp team. WhatsApp group also.
Oh, okay.
Is this
So,
one?
let me check your score. Is it? Let me check your score whether you got the perfect
Okay.
score.
Okay.
So, I'll go back and check your score whether you have a perfect score or not. So, okay, my module. Okay, yes, okay. Let me check your score here. Okay, quick center. Quick center. What is your name? I think name. You say you try already. Let me see what is it. Okay. Yeah, you actually got the perfect score, right? Okay.
Oh, okay. Thank you.
Okay. So your name is actually. Let me see whether your name is there.
My name is Jiang Lei.
Oh, Jiang Wei. Okay. Okay. Fine. Okay. Jiang Wei. Jiang Wei is the last person. Yeah, okay, thank you.
Thank you.
Yeah.
So, Mr. Quack.
Yeah, what is it?
Some of the questions, do we need to plot the curve or not?
No need, but there's not, no need, nobody asked you to put a curve.
Okay.
No question about plotting curve, right? So ask you which one is the correct graph, maybe, is there? Not sure, maybe. Okay, let's see how is everybody performing. So I can
So it's
see
just
the score straight away from here. So let me go back and see center.
I don't get how does the hyperbola and the parabola what parametric equation is like a hyperbola or parabola equation, something like that.
Okay. Only go center afterward and talk about this.
Sure.
Yes.
Can I check? Can you check my answer, please? Cause like just now I got put answer, right? I submit the answer, but then I think they never save my answer, and then they just submit it.
Okay lah. So I can check now.
Yeah.
Okay.
Okay. Thank you.
angry, yeah.
Okay. So far, who haven't submit yet? Okay. 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 Dong Yi Hai haven't submit yet. Dong Yi Hai haven't submit yet. No. Hana haven't submit yet. I think some of you are okay. Zachary Samuel haven't submit yet.
Just submitted.
Okay, thank you. Okay, Fabian haven't. Fabian submitted. Phân, okay, Phân Hao Yuan.
So I submitted already.
Okay, any more? Richard haven't submitted. Richard Lim.
Yeah.
Okay, Shi Jia Ping haven't submitted. Okay, Xin Zhi Zhen haven't submitted. Okay, let's see how just update the score. I mean, how it works. Okay, so go back again. No. So I need to go back to the score. Grid center and focus center. Then manage the class. One. Okay, Jiu Xinhua, I think you got very low score. What happened? Last week you actually did the tutorial, right? Win kind. So Joshua done 30. Okay. Now An Jie 20. no win pen 20. Okay, almost everybody submitted already. Oh. Okay, 施家Ping, I haven't submitted yet. 施家Ping, I haven't submitted. Okay, so that's only one of you haven't submitted yet. Okay, not sure what is the situation. All right, hope everyone submit already. Only 施家Ping haven't submitted yet.
Sorry, my laptop lag just now. Yeah, then I restart. Yeah, I submitted, but then they say overtime.
Oh, what time?
Yeah.
I think I submitted already.
0.
No lah, let me see again whether I can come back again. Press center, forward center, and this I mean see and and then I just go and check here. Yeah, okay, I think I need to do something. Okay, let me mark for you lah. Okay, so the magic curve. One. Okay, so I mark for you now. So save and exit. So you can continue mark here. So maybe I'll talk about this. I think because I think you have no let's see. Okay, what is the question? So okay, I should not talk about this one. Then maybe next week I talk about it. Okay. Okay, so let's go back to the lesson. Okay, so we continue the lesson. Then also I talked about last week tutorial. Okay, as well as there are some other questions I have not mentioned. Maybe some of you have done already. Anyway, so I'm going to continue the lesson, which called the chain rule. Okay, the real chain rule right? So before I talk about chain rule, okay, this is the chain rule. Okay, so the simplest one. Okay, there's a hard one chain rule also, but this is the simplest one. Suppose x is a function of time and y is a function of time. Okay, now if you have a z depend on x and y. Okay, because z depend on x and y, so we know that when x change and y change, z will also change, right? So how do you measure the rate of change of z in time now? So this is the using partial differentiation. You can actually find the chain rule. Okay, this is the simple chain rule. Z depend on x and y. X and y depend on time. Then you got this thing. Okay, this is actually extension of usual chain rule. So I'll look at example 12. Okay, example 12. Okay, how to do this? So use the chain rule to find dz dt. So what does it? So first of all, z is equal to x squared y. So first z is equal to x squared y. So you can find dz dx first. You get 2xy because keep y constant now. Then you can dz dy also. You get x squared. Okay, so you can find, okay, if your x is going to change depend on time, you can see x and y depend on time now. So dz dt is equal to partial differentiation versus the x here and dx dt. But partial differentiation versus the y, dy dt. And this is the usual simple version of chain rule. So you get this 2xy and dx dt is 2t. Well, dx dt equal to t, yeah. So dx dt 2t, and then dy dt is 3t squared. So you can do this. So x squared 3t squared. So you put the x back and y back last, so you get x equal t squared, y equal t cubed, then 2t, then x equal to t squared, then 3t and y 3t squared, right? So altogether, this is 4t6 plus 3t6, right? You get 7t6. So this is applying the chain rule directly. Okay, so this is how you get this using chain rule. How about part B? Part B, what does it ask you? Check the answer in A. Expressing z as a function of t now. You can see that. So z equal to x squared y. And x squared, x is a t squared now. Y is t cubed. So altogether is t7. So dz dt, and no surprise, is 7t6. Okay, same answer as we expected. So this is example 12, illustration of how to apply the simple chain rule.
Mr. Quack, can I ask a question?
Yes,
How you get 7 plus 6 for dz dt?
7 plus 6 dz dt. Okay, then okay, let's look at here.
76.
76
7? Oh, okay, okay. Oh, sorry, okay, thank God.
So this 76 Okay, this is 76 now. Okay, so far, so right. This one example 12. Example 12, straightforward, no messy calculation. Okay, if not, I move on. Example 13 now.
Then why not we just use the B formula then can already, right?
Which one? Part A,
We
is
use
it?
the B formula. B formula the fastest one.
And of course, this is just for you to comparison, because
Yeah, but then
it's not
if your equation complicated, then next one you cannot use the formula.
Yeah, okay. If equation complicated, then yeah, then you know that is you put together myself actually do this part A. Okay, actually, usually part A is a simpler one because you break up into smaller term. Right? Part B actually combine together, right? But it's not always easy to combine together. Okay.
Okay.
All right, then we're going to move on to example 12 now. So, 13, okay, so show you the, all right, so you see that I'm so afraid that I could make a mess for this calculation, right? I know this is going to a mess calculation. Okay, so this time, of course, you can actually put everything in terms of theta, then you find dz theta. So actually, it's possible, no? If you watch my video, I show you my calculator can do differentiation, and straight away give the answer already. Okay, you can put there, you put x equal to y, you put x cosine theta, y cosine theta, and then you differentiate the theta, the function can do differentiation, then you straight away give the answer already. Right? Anyway, just a side note here. So we're going to find out what is z depend on them. So we have a z depend on x and y first, which is actually, let me use, instead of using a red pen, the blue pen now. So this calculation will be messy here. Okay, this function of x and y now. So this is actually square root of, or you can say square root of xy plus y. So xy plus y square root here. So I need to do something. If I use a chain rule, z depend on theta now. dz d theta. Okay, I want to find out this one is partial difference z with respect to x first, then partial differentiation of dx theta. So that's why is this d normal differentiation now, okay? Because x depend on one variable only. Okay, x depend on one variable only, theta, and then dz dx partial differentiation with respect to x, y first, then dy d theta. Okay, so what is df theta here? So df theta is actually, you can find out df theta is minus sine theta. dy d theta is cosine theta now. This is normal differentiation, and whereas x and y is a partial differentiation. Okay, let's try to figure out what is dz dx first. Okay, this is equal to, you keep y constant now, so half x y plus y minus half, then differentiate with respect to x here. Differentiate with respect to x, you get y. Okay, x y differentiate with respect to y, and then plus 0. So this is actually half of y over square root of xy plus y. Okay, then partial differentiation of z with respect to y. Keep as constant now. The same first term. Then differentiate with respect to y. So xy, you get x here. Then 1. So this is actually half of x plus 1 over square root of xy plus y. Okay, so I'm going to put them inside now. So this one, dz dx here is here. And then dz dy is this one. See what is this now? So most likely you're going to make a mess out of this. Okay, so let's put it in. So half of y xy, or maybe I don't do this because I'm going to put the x and y anyway, just because if I do this, it make a mess also. So this one, dx d theta is minus sin theta here, and half of x plus 1 over xy plus y, and times dy d theta is cosine theta now. Okay, so now what is that? I try to what is actually going on is that theta is pi over 4, right? So what is x here? So x, let's try here. X is cosine theta. Theta is pi over 4. So this is square root 2 over 2. Okay, x is square root 2 over 2. And what is y? Y is sine pi over 4. This is square root 2 over 2 again. Okay, so and then you have an expression. What are all these things can put it in? So sine theta is sine of pi over 4 because you put theta equal pi over 4 now. So put theta equal pi over 4. So sine pi over 4 is minus square root 2 over 2, right? So okay. So what you have is y equal to square root 2 over 2 over x is square root 2 over 2, y is square root 2 over 2 plus square root 2 over 2, and this is minus sine is minus square root 2 over 2. Okay, plus half. X is square root 2 over 2, and this one also same. Square root 2 over 2, square root 2 over 2, plus square root 2 over 2. And then cosine theta is square root 2 over 2 here. Okay, so then all you need to do is press calculator, right? So what do you get? Hopefully you press correctly. Okay. I think let's do it slowly here. So the first term, what do you get? Okay, first term, okay. So I know this is very hard, yeah.
0.32.
So 132
0.322.
322
Yeah, haven't yet. Yeah, no, actually not. We haven't yet.
Got negative sign in front.
Yeah, this one got negative sign,
Yeah,
right?
negative 0.322.
Negative
So negative 0.228.
Huh? You got press correctly or not?
Yes, I press already.
You press again.
Because I think this is going to make a mess, right?
Right.
I look at number like this. Wow. Or you just maybe makes things easier. You just say so many square root 2. Maybe you can this one change all these things to 0.07.
Oh, legit. Okay.
Square root 2 over 2 is 0.07, right?
0.707. Yes.
Okay. So
Sorry. Oh, wait. Okay, then can then I try.
Do you square root the whole thing below? Nah?
Yeah, I did. That's 0.7.
okay, this is actually testing your concept.
You'll get about minus 0.118.
Okay, minus 0.18. Let's check answer.
Yes, that's answer.
This answer, right? My calculator show that. Okay, I don't know this one. My answer. 0.2217.
Wait, see. No, I mean like for the first part, yeah, for the first
First
part.
part is negative.
So
So why yours no negative?
No, my first part is negative. First part, yeah. Wait, let me see. X plus 1. Oh my wait. I try do the entire thing. 0.707 plus 1 times 0. Oh my god. Hold up.
okay, how do you do it? What you do is actually what you do, right? Is actually
Yes,
let me see. You can add them up first.
Yep, I know.
Okay, the other divide by the denominator common.
Wait, my answer get 0.4355, like this one.
Let me see. Minus 0.
Sure. I simplify all into sin theta and cos theta only.
Yeah.
And after that, just start the value in.
Yeah, correct lah.
Then but my value is negative of yours.
Then you're wrong lah, walao eh.
Answer correct, where go wrong one? Negative sign, bro.
Okay. So okay, so I mean, okay, I'm not interested to actually get the answer out. Okay. Anyway, I show you that the calculator show me the answer straight away. So the answer. Okay. So this is answer.
Oh my. Okay, never mind. I can.
Okay, so let's move on to the next one. Right? So this is not very interesting.
Yes.
The interesting one is actually okay. The interesting one is actually I show you manually. Okay. So this part, okay, working how to actually come up with answer. Okay. And every time I did this, maybe it's not every time I do the get the same answer. Okay, it's true. So I see that.
Yes, sir.
Okay, so I'm going to move on to the next part, which is application now. Okay, this question 14. Let's look at the question. Yeah, okay, this is something we there is a portion of a tree that is usable for a lumber, maybe used as a right circular cylinder. So you can consider this the right circular cylinder. Okay.
Actually, what's the meaning of the right circular cylinder and the circular cylinder?
Circular cylinder, right circular. Because circular cylinder may not be right angle. Right circular cylinder must be right angle. Upright means because there can be cylinder like this one. Right? So Then one need to be right angle one, right? Straight one.
Oh, okay, nice. Okay, I get it now.
And the height of the tree increase at 0.2 meter per year. So there's height there. So height increase, right? Height here.
Yes.
So, and then, so you can write that height increase is 0.2 meter per year. Diameter also increase. So diameter D, let's say D is diameter, yeah, increased by 0.03 per year. How fast is the usable volume of the lumber? Where's the rate of change of volume now? Yeah, rate of change of volume is when the tree is 200 meter high, and the diameter is 3 meter.
Okay.
And these are information. So you must know the volume of a tree there, tree trunk, okay, pi r square, base area, right? Base area times height. So this is pi r square here times the height. This is base area times height here. So I want to find differentiation. Before you do this, you can use the chain rule here. It's differentiation of V with respect to R first, because V depend on R and H now. Okay. V depend on R and H here. So V is a function of R and H here. So differentiate with respect to R, then the RDT, and differentiate with respect to H there, then DHT. And this is the usual chain rule. Now differentiate V with respect to R, you will get, keep H constant, get 2 pi RH. Okay, differentiate R with respect to T given to you is 0.2, so 0.03, or what is it? It's not correctly, huh? So, this one is
should you convert the radius to diameter instead?
yeah, okay. Should we?
Another side. Okay, never mind.
I think this is okay. What you do is diameter is half of radius, so basically it means this thing differentiate radius is actually equal to
0.015.
0.015, right? So use it, so 0.015. Okay, differentiate V by the H now, pi r square, and then the HCT is 0.2.
Okay.
So put all this together. Okay, this is a simple calculation, no messy calculation involved.
Yes.
So, okay, this one should be quite easy here. 2 times pi times r. Okay, r is equal to 1.5, no?
1.5.
Okay, that means r equal 1.5. Okay, times h. H is equal 200, sorry. Then times 0.1015. So the first term is 9 pi first. Nice number. Second term is 3. R is 1.5 here. 1.5 you square it. Okay. Times pi. Then times 0.2. 9 over 20 pi. Or so altogether it plus 9 pi here.
Yes.
Okay, so convert to decimal point. 29.68 now. So this is meter cube per year. Okay, so this is example 14. Okay. Okay, now I move on to the next example. Okay, so next example now. Okay, I'm going to use a chain rule again.
Mr. Quack,
Yes.
in chapter 2, just all about like chain rule, product rule, partial differentiation.
Which one?
Like chapter 2.
Yeah.
Is it all about product rule, chain rule, then quotient rule, so what?
Not
Partial
really,
differentiation.
not really. This is just a beginning only, right?
All
The
beginning.
behind, you look behind, there are a lot of other stuff. Okay?
Alright.
So, but I'll go through this one in the beginning level first before I move on, right? So you can do a chain rule simple one. Let's see how you apply this one. Even chain rule is not so easy to get out. So this example, okay, so I want to use this as an introduction of how do you apply this. Okay. Okay, let's try to understand this first. Suppose z is a function of x here and y. So we know that dz dt is partial differentiation of x first, then multiplied by dx dt plus partial differentiation of partial to y, then dy dt. Okay, this one we agree. Nothing wrong with that. Now, what happened if I change the t to x now? Okay, I change the t to x now. Now, so what happened is now I want to change the formula so that change t to x. Okay, then you can actually get something like rate of change of z with respect to x there. So there is no change. Okay, but your t change to x now, and then there's no change, but your t change to x now. So from here, dx is 1. So you have dz dx is equal to df dx plus df dy dy dx. Okay, so it becomes like this. Now, suppose z is a constant, because usually if z is a function of x and y, usually for implicit differentiation, suppose this is actually equal to a constant. Okay, suppose this is equal to a constant here. So where is it now? So this is constant c. So f function of x and y is a constant c. Therefore, you differentiate dz dx, you expect to be 0. Okay, so when that happens, then you have what now? You have df dx, partial differentiation with respect to x here, plus partial differentiation with respect to y, dy dx equals 0. So that means that you can rearrange them and get dy dx is equal to, okay, dy dx is equal to something like this now. Okay, after you got this already, so then you can change what is dy dx now. Dy dx is negative of df dx over df dy. Right? So provided the denominator not equal to 0, so you can do the partial differentiation to help you to find the dy dx. Okay, you can actually find a dy dx by using partial differentiation, which usually is easier. If you do directly, you find that sometimes it's a bit hard here. So this is the part how to do implicit differentiation this way.
Mr. Kwek, I have a question.
Yeah.
You write there change t to x. Where does t come from?
Change t to x.
Yeah, where does t come?
Because initially, this is actually, okay, initially you have, anyway, okay, initially this equation, right? Now I can modify the equation by changing the t, all the t change to x, right?
I see,
Okay.
yeah.
All the t change to x, okay?
Mm.
So all the t here change to x now. T.
Okay, I understand already. Okay, I see it. Yeah.
Okay, all the t change to x now. Then you got this new equation, and this is how you can modify here. If this is equal to c now, constant, then you expect this equal to 0.
Okay, so the condition that it must be equal to c lah, a constant.
Yeah.
Okay.
Otherwise, then you cannot solve the equation. Nothing. Yeah.
Thank you.
Wait, Mr. Quack, that means if it goes to 0, right, that means it's like reach a minimum point, a stationary point, or something like that idea.
Not really, no, because
Not really,
because differential constant gets 0.
Yeah.
Even c constant, so differential c you get 0. So in this case, you can actually solve dy dx from here, okay, at any point using the implicit differentiation.
Okay, thanks.
So the last example, I'm going to talk about this one, okay? So let's look at the last example and talk about this one. Example 15 now. Okay. Using this method now, okay, I can use this method to find dy dx using partial differentiation. Then you can compare. So what you can do is you write this expression as function of x and y. So what you do is let z equal to x cubed plus y squared x minus 3. And you want it to be equal to 0. So this is a c here. Okay, c equals 0 now. Okay, z is function of x and y.
Mr. Quack, is it okay to put your z as 3?
Z equal to a function of x and y. Yes, you can also do that. Okay, so that means that you can put it as a x squared by y squared x equal 3 also can. Right? Yes, you can put it so 3 okay. Right? So I just want to make sure that you can z equal to, okay, put it equal 3. Okay. So you can put it equal 3 now. You can. So you want, let me see, put them equal 3 now. Because it's supposed to be equal 0. First, move 3 over. So this is C now. So now you want to find dy dx, right? So dy dx here. Then you can do the partial differentiation first. Partial differentiation of f with respect to x first. You get 3x squared plus y squared. Then partial differentiation of f with respect to y is only 2yx. Okay, z is function of x and y, so this is fxy here. Now the formula of dy dx tell you that this is equal to negative a partial differentiation with respect to x over partial differentiation of x with respect to y. So this is equal to negative of 3x squared plus y squared over 2xy. So this is using partial differentiation. Okay, partial differentiation is easier, okay, because you just differentiate one variable at a time. Okay, we can also get the same answer by using the usual implicit differentiation, then we compare answer, okay? Okay, so I move on to show you how to use implicit differentiation usual way. This is the EM1 method or EM1, I think. EM1 method, okay, this one. So insert first. The EM1 method is this one, okay? Yeah, go back to EM1, this is what you do. People, O level student, A math student, usually want to do this.
Okay lah.
Okay, 1 square x minus 3 equals 0. So what you do is differentiate everything with respect to x first. Then minus differentiate with respect to xi. So we get this thing. Differentiate 0 equals 0 here. So differentiate everything with respect to x, you get 3x squared here. This one is tricky now because y is the function of x here. So get product rule first. So get y squared, keep the first term. Differentiate the second term. Then keep the second term. Differentiate the first term with respect to x. And then this one is 0. So you apply the product rule here. Okay, so I know this is 1. So we get 3x squared plus y squared. And then this one is how to differentiate y squared with respect to x again. You can differentiate it with y squared first. Then dy dx. So this is where the chain rule come in. Right? Change the x to y. Then you have 3 chain rule. And then the other one is 0 here. So get 3x squared plus y squared plus 2xy now dy dx equals 0. So from here, you can rearrange them now. 2xy dy dx is equal to negative of 3x squared plus y squared. So you get dy dx minus 3x squared by y squared 2xy. Okay, you can see that I get the same result as before, but I think this method a bit more complicated, okay, because a bit sometimes I forgotten, confused already. There's so many things. Use product rule there, chain rule there, and there's a product rule. There's a chain rule here. So product rule here, chain rule there, right?
Wait, so after this example, we go straight to the tutorial already.
Yes, you can do tutorial, but I think go through also tutorial 1 review some of the question that you may not be aware of. There's some of the question I'm not sure you've done it. So for example, question 8, question 7 and 8, right? Let me
Yes.
go through them also review since I know.
Can we have like a 5 to 10 minute break, because I need to go toilet, that's why.
Okay lah, so let's wait for 10 minutes, okay? So 15 minutes break, okay?
Thank you.
Okay, 15 minutes break, okay?
Okay.
Thank you.
Oh, party!
Okay, so everybody back already.
Mr. Kwek,
Yes.
for question 8 of the tutorial, right? Have you taught before?
Which one? Tutorial 8 or
It's
tutorial 1
about
is
the
it?
direction. Yeah.
No yet. Because that is
So-
different question.
That's for the next class.
Let me see. There is question 8 I asked you to do, right?
Yep.
So let me see. Question 8. If you okay, the direction of maximal decrease or maximal. Okay, so this one actually look like directional derivative. Okay, so not very good question. So this one will be KIV first.
Okay, so not this week lah, submission.
Yeah, not this week.
Okay. Thank you.
Sorry, Mr. Kwek, what are the questions to do again?
Okay, so KIV this one. Question 8 I think is not this week. KIV first.
Okay, thank you.
Okay, 9. Okay, so let's question. Let's turn to the tutorial question. Okay, so afterward,
Mr. Kwek, are you marking attendance?
yeah, I'm going to mark attendance. Don't worry, just okay. At the end of the class, mark attendance. Okay. So let's look at what question 7A first, tutorial 1, because I did not assign this to you. So let's see how to do this. There are many possible answers. Just look at one possible answer here. Your line segment joining -1, -3, and 4, 1. So how to do this? Basically, the best way to draw a picture first. Imagine that what is actually this curve. Okay, -1, -3. So minus 1, minus 3 is somewhere here. So this is minus 1 and minus 3. So this is 1 point. And 4, 1. Okay, 1, 2, 3, 4. 4, 1. Okay, so this is 4, 1. Okay, minus 1, minus 3. So line segment is actually a straight line joining these two. Okay, there are many ways to do this. So let's see how I do this. I want to see the difference here. So how to get this straight line? Parametric curve means x is a function of time. Okay, x is a function of time. Y is a function of time. So what is this x and y now, so that you get this straight line? So one way to do this is, okay, there are many ways to do this, but I think if I look at the answer, I can put it, okay, the simplest way to look at answer, okay, I want to put it in such a way that t equals 0 at this point. Good, parametric curve, let's say I say I want to put t equals 0 here. I just, not necessarily must t equals 0, but t equals 0 here at this point. I want so t equals 1 here. So there are many possible answers. So this one possible answer here. So t equals 0, and then t equals 1. Okay. So anywhere in between this any xt down, xt yt, right? It's a straight line. So I'm going to use something like proportion can actually get this. Let's see, t equals 0 and then t equals 1. So how do I get this? Okay. So I want the t equals 0, x equal to minus 1, and t equal to 1, x equal to 4. Okay, look at this. So my argument is this: when t equals 0, x is at the point minus 1. When t equal to 1, x equal to 4, right?
So how you get the t equals to 0, t equals to 1 thing?
No, I just arbitrarily set as a no. So t, you can actually put t equal to minus 1, t equal to 1 also can. T equal to minus 3, what t equal to, means I just set intervals for my own calculation, easy calculation.
Okay.
Okay, so parametric curve has many possible answers. Okay, even the parabola, you can see some of them different. I show you because I think you have quite a few possibility. Okay, so I want to set it in such a way that, okay, when t equals 0, x equals minus 1. When t equals to 1, x equals to 4, right? So this difference is how much there? This difference between x is 5. Okay, 5. Correct? Minus 1 to 4 is 5, right? So I can put a difference, I put as equation there. So x equal to start with minus 1, when t equals 0, x equals 5, 5t. You see that when t equals 0, get minus 1. When t equal to 4, so when t equals 1, you get minus 1 plus 5, you get 4, right? Correct. You try to feed the data. So you see that I get this one. When t equals 0, you get -1. When t equals 1, -1 plus y is 4, right? Which fit nicely into data. Then I'm going to do the same thing. This is how people work. Okay, work with it. Okay, when t equal to 0, your y is equal to -3. When t equal to 1, your y is 4. 1, right? So difference between -3 and 1 is 4. So start with when t is 0, you can say y equal to, then try to feed the data. When t equals 0, you get -3. Then 4t, when t equals 1, you get 4. 4 minus 3, you get 1, right? So just nice. Okay, this thing go inside there. Okay, so this is a parametric curve. So we put t, okay, t from 0 to 1. So this is why I get one possible answer there. And this is not the only answer, no? Then I can put my t into something else. Then you can try other possibility.
Wait, I don't get the -3, like y equals to -3. What is that?
Okay, let's see, -3. So when y equal to -3, let's see, when t equals 0, your y is equal to -3 here. When t equal to 1, your y is 1.
Okay, yeah.
Right? When t equals 0, your x is -1.
Yes.
Okay? When t equal to 1, your x is 4.
Okay, Cup.
Okay, so that's how you get parametric equation. This is actually from AIM2. But I think most likely you've forgotten already.
I forgot already.
Yeah.
Can you like teach me overallly or something like that? Yeah, briefly, then teach me how to do this thing again.
Okay, so you must know how to find the equation of a line segment. Okay. Okay, so let me go through the line segment again. So this is for AM2. Okay, right? So let me go through line segment again. So, okay, suppose you have a line, straight line. What is the equation of straight line?
Y equals mx plus t.
Oh, this is a 3D line now.
3D. That don't know already.
So you usually have a point, fixed point.
Yes.
R0, fixed point. So this is x0, y0. Okay. Then the general point, xy. When you talk about straight line, you have a direction, v. So any point, position at any point, r here, r is equal to fixed point plus the direction of v, tv. Okay, v is here for the straight line here. If you remember, equation of straight line, there's a v direction, and then there's a fixed point. Okay, so usually if you say r is equal to r0 plus TV. V is usually a vector fixed point AB. Okay, fixed point is R equal to fixed point x0, y0 plus TAB. So if xy, general point is xy, xy is x0, y0 plus TAB. And so in this case, that's why the parametric equation says x equal to x0 plus T A okay, y is y0 plus TB. And that is how you get this equation of a straight line. Okay, usually this is we set usually okay, this is when t equals 0, fixed point. This is the endpoint somewhere here. So right, endpoint somewhere here. So this is another endpoint. So x1, y1, t equal to 1, for example. You can set this in this way. So easily to fix the point, right?
Yep.
So for example, the A in this case, you can see from the earlier example. Okay, first point is x0, y0. So this is x0, y0. This is x1, y1. So the A is actually 5. Okay, -1 to 4. Difference is 5. Okay, the A is 5. Then second one, the B is 4 now. Then this actually the equation of straight line. In AM2, we have this one. Okay, just a recap. Equation of straight line. This is called parametric form. Okay, parametric equation of straight line. So line segment also same. Okay, so basically this is what for 7A. Okay, just to recap something you learned AM2 before. Now, okay, I want to talk about question 7B now, right? 7B. How to you set up a parametric equation of a half of a parabola. Okay, so far this one all right. This is something you learned before. Just recap and just show that this is actually the same principle.
No, but then since you say that the x0 like is 0, right? T equals to 0 is equals to x0. But then why is it like -1 there?
Okay, -1, x0 is -1, okay? x0, y0, fixed point. So you have a fixed point, -1 because here, the first point is -1. This is the x0, x0 is -1, okay?
Okay.
So x0 is -1. Yeah.
Oh, okay, I think I know already. Yes.
Okay, y0 is 1, okay? So this is okay. X1 is 1 now. So
okay.
All right. So you see the corresponding, right? So how these things are linked together. Okay.
Thank you very much.
Okay, now I want to talk about this parabola here. Question 7B, right? This is still question 7B. Lower half of parabola, okay? So these have this x equal to 1 plus y squared. So what is this parabola? If you change the x and y, right? So this graph will look something like this. So you can say that with x, y equal to 0, x equal to 1, fine, right? So y equal to -1, then x equal to 0, right? No, sorry, x equal to 2.
Yeah.
Yeah. So when x equal to 1, also 1, x equal to 2. Okay, so this parabola, if you look carefully, okay, x and y axis here, x equal y equals to x equal to 1. Now, however, the parabola x equal to 2, y equal to minus 1, and sorry, y equal to minus 1, x equal to 2, right? So y minus 1 here. So this parabola looks something like this. Okay, this parabola like this. This is actually x equal to 1 by y squared, but they only want the lower half. That means that only the parabola cannot be upper half. I want the lower half only. I want this one.
Okay.
Okay, how do you write the answer? So you have a parametric equation, right? You must have x and y.
Oh, that one.
Okay.
Yeah, but you must
So-
restrict your y because it's lower half.
Yeah, your y must be less than 0 now. Okay.
Less than
So
equals
make
to
sure
0.
that okay, you just put x equal to t. Sorry. You put y equal to t. Okay. But t less than 0. Then x equal to 1 plus t squared. That's why you can answer like that. Right? Just change the y. Put y as a parameter here. You put y equal to t, but t less than 0. Okay. Then that's why the answer like that. Okay. So x equal to 1 plus t squared. Okay. You get a parametric equation already. This one way. This is question 7b, right? How to actually come up with a simple. So one of the simplest way is actually turn one of the variable into the parameter. Then you get the same equation, just simple way, the parametric equation. Okay, so this is question 7b. So I'm going to talk about question 8 now. The low one. Question 8, right? I want to find the distance between 2 points. So there are 2 points in a plane using polar coordinate. So there's a 1 point. So let's say draw it properly, huh? So there's 1 point here. So there's 1 point. Let's say this is actually the position. Distance is r1. Angle is now theta 1. So this is r1, theta 1. Okay. Then there's another point. So the point is somewhere here now. So there's another point. This point is further away. Let's say this distance is r2. And this angle is theta 2. So this point is r2 theta 2. Okay. So I want to find the distance between these 2 points. Okay. Find the distance. Where's how to find the distance between these 2 points? This is the distance now. Okay. Distance between these 2 points. Straight line distance, right? So how to find d? Okay. Distance between 2 points is you can use that. Okay. Where is this angle now? This angle is theta 2 minus theta 1, right? Then use law of cosine finish really. So d square is equal to distance now is r1 square plus r2 square minus 2 r1 r2 cosine theta 1 plus theta 2. Okay, finish. I take a square root, the answer come out. So d is the square root.
Oh, we use the formula sheet, the thing, right?
This is a law of cosine now, right?
The formula cut formula, yes.
Yeah, we have to apply it lah. you don't directly look something like this, but you apply, just apply formula card. Okay, so this is chapter 1. I think I finished chapter 1 already. Chapter 2, there are tutorial form. Because I think you need to know the simple one, because I didn't assign to you some simple calculation. So you must do the practice. For example, even though I don't ask you to do, I think, question 2 or question 1, okay? But the thing you need to practice also, okay? Because otherwise, then you don't know how to do the simple one. So, okay.
So basically, you must do all, can
Cannot lah, because now we haven't finished everything yet. So,
okay.
let's see what are the things I can go through with you later on. Okay. Question 8 cannot do at the moment. But I think question 4 I will talk about this. Okay, because question 4 I will talk about this later on.
Okay.
I will show you how to do question 4. Okay. Question 1. I think you do question 2, then you should be able to do question 1. So not necessary, but you want to try also can. Okay. So I will talk about question 4 later on. Let me mark attendance first.
Okay.
So mark attendance first. So let me go through the attendance one. Okay, so I can get class attendance. No. So I have to go back to the SAS again. Strange. Oh, I know why I cannot mark attendance. Okay, I know why I cannot mark attendance. Because I need to do VPN. Why?
Oh, VPN. Okay.
If I don't do VPN, I cannot mark attendance. Okay. Okay. VPN mark attendance. So 4, 8, 1, 5.
Yi Hao, your ringtone is the Indian copy number.
Okay, so attendance, wait for this happen. No. Okay, so coming out really. Attendance, checking, more attendance, checking, search. CLS. Okay, so today is 27 already, huh? Okay. Okay, so I'm going to share the screen with you first. Okay, this is one round. So share the screen now. Okay, so I think you can see yourself screen now. So Joshua Tan, okay, here right? Joshua Tan.
Here.
Okay. Phong Hao Yuan are here. Phân Hao Yuan.
Here.
Thank you. Dong Yi Hai are here.
I'm here.
Okay. Wang Zhenqi are here.
I'm here.
Okay. Teo King Han.
I'm here.
Okay. Zakaria, okay, Samuel.
Yes.
Okay. So Hui Sun, Benjamin.
Here.
Lao Ang Jie. Lao Ang Jie, this one. Lao Ang Jie, I think you're here. First, okay, afterwards, huh? Su Hin An, Sebastian.
I'm here.
Okay. And then Richard. No, Fabian first. Fabian Tang.
I'm here.
Okay. Richard Lim.
Here.
Okay. Lu Yuen Peng.
Not here.
Okay. Sui Jie Peng.
Yes, I'm here.
Okay. Okay. Go Zhang Hong. Go Zhang Hong.
Here.
Okay. Wu Jiayi.
Yes, I'm here.
Win Ki.
Yes, I'm here.
Okay. Lim Yi Hao.
Yeah, I'm here.
Sim Chi Zhen.
I'm here.
Jiu Xin Hua.
Yes, I'm here.
Jiang Lei.
Here.
Okay.
Not here.
Nohana.
Here.
Okay, thank you. Just now I missed the person name is Lao Anjie. Are you here? Anjie. Lao Anjie, not here. Oh, let me check the name list. Lao Anjie. So,
He replied message.
oh, he replied actually. Okay, fine.
Yeah, his mic got problem, but he here.
Oh, okay, fine. So fine. So everybody here.
At home still not here. Don't need to come anymore already.
No, somebody is not here. One, okay. Okay, so okay, let me see. It's not over already. So I just okay. I beat out everybody here. So check, and then there's another one. Okay, which is I no need to mark. Okay, just say what do. Okay, so let me say something about how to do some of the question. Let's say example 4. No, not trying. Something about maximum, minimum. Okay, something you learned before. So I want to mention about how to do question 4, right? So this is something is good to know. Okay, question 4. Okay, what happened? The function is f of xy equal to 3x squared plus y squared.
Teacher, you need to share back your screen
my
to
phone
the note.
Okay, and then I do share, right? So let's share first. So go back and then start sharing now. So I go back. Okay, where is now?
Yes, sir.
This one. Okay, this one. 3x squared plus y squared. Okay, 3x squared plus y squared minus 4x minus 6y plus 2. Okay, this is a function of x and y. So the question is, find the minimal value of f x y at when y equal to minus 1. Okay, what is the minimal value of this when y equal to minus 1? So what you do is just answer the question when y equal to minus 1, what is the minimum of this thing? So put y equal to minus 1 as, then you get f of x. Okay, y equal to minus 1 now you get 3x squared, then minus 1 squared, minus 4x, minus 6 times minus 1, plus 2, right? Because of y equal to minus 1 now. So this is a function of x now. So this is actually 3x squared minus 4x, okay, plus 6 plus 2, you get 8 minus 8 plus 1, so 9. Okay, so 3x squared minus 4x plus 6 plus 2 plus 1, so this is a function now. So I want to find a minimum of this. How to find minimum of this thing? Normally, when you find minimum, you do differentiation, right?
Yes.
So you find differentiation df dx first. Okay, so this is actually no partial differentiation, then normal differentiation now because of y is minus 1 now. So this is actually 6x minus 4. Yes?
The question say y equals 1 and not y equals minus 1.
Y equal to 1.
Yeah.
Okay, y equal to 1. Okay, so it's 1 here.
Yeah, it's 1.
1 here. So this thing actually 1 here. Okay, it's 1 here. So y equal to 1 here. So it's minus 6 plus 2 is minus 4. Minus 4 plus 1 is 5. Minus 4 plus 1, minus 3. Okay, so you find that to find the minimal, you need to get x equal to 2/3 now. Okay, so when x equal to 2/3, what is the minimal value of y now? Is this minimal? How do we know this is minimal? So you know differentiate another time.
Yes, then you can, then if a positive is a minimum, then if like a negative is a what's that called, maximum. Yes.
Yeah, because this one is minimal here. It's minimal here. Minimal. T by d is 0. T2x t positive.
Show the shit, Joker.
Yeah, this is how people remember that this is minimal. This is minimal here. This is 0. Dy dx 0. And then d2y dx square positive.
Oh my god, insane.
Right? Of course, to get another one for set phase. Set phase of the other opposite now. Okay. So all the cube picture come in and to help you remember that's not minimal. So this side will help you make some minimal later on. And this kind of picture here. Okay, so you know that this is a minimal, and the minimal value is when x equal to 2/3, right? So when x equal to 2/3, so minimal y. When this case, when minimal fx, sorry, not y, minimal fx. Anyway, y equal to minus 1, y equal to 1 here. So you get 3 times 2/3 square minus 4 times 2/3 minus 3. Right? So I hope the answer is correct. This is question 4. So based on this, question 4 is minus 13/3. Okay, how to find the just help you recall something you learned in O level or A max last time or EM1. Okay. Okay, this is the minimal of the function. Okay, this is for A. So what I want to answer for B.
What's the question for B?
Okay, now I'm going to show you a question for B.
Thank you very much.
A finish already. Question for B. For B now. Okay. Explain why answer in A. Okay, answer in A is not a minimal. Of the function. Okay, explain. You can actually find the minimal. Okay, you can actually find a minimal. Where is but there you can actually find a function. First of all, you can see this is a function first. The function in actually is 3x squared, okay, plus y squared minus 4x minus 6y plus 2, right? This is a function here. And just now we find the minimal is a minus 73. Answer earlier in part A is when y equal to minus 1, y equal to 1, you get actually function f of 1 is minus 17/3. Okay, we find out that, okay, the minimal in part A is minus 13/3. Okay, so
yep,
all you need to do is to figure out an x and y. Okay, figure out x and y. That will give you a number less than minus 13/3. Then you show that answer in part A is not the actual minimal. Okay, because they are actually there is minimal for y equal to 1 only. If y equal to some other value, okay, for y equal to 1, you get minus 13/3 is a minimal. What about y not equal to 1? Okay.
So it can be maximum also, or maybe it like
this one, unfortunately, there's no maximal in this case.
Okay.
This function has no maximal, but you can try many. For example, you put x equal to 0 first. Okay, let's see what you get. Let's see, because in the answer say that you can put x equal to 0 first and then compare.
Okay, I think for all values of y, it won't affect the fx. Because yeah, for all values of y, if you sub in, right, your fx will still be the minimum of that value.
Yeah.
Yeah, so you only have to change the value of x only.
Yeah, okay, let's see. 0y, right? If I put 0y, what do you get? You get y squared
minus 6y plus 2.
Plus 2, right?
Yep.
So where is the minimal of this thing? Okay, this one you can find out, okay, yep. Minimal, you differentiate by to y, right? So
2y minus 6.
So get 2y minus 6, right? So y go to 0 here.
Yep.
Okay. So y go 3. So the minimal you can get this one is 3 square minus 6, 3 plus 2. So you actually get a number which is 9 minus 18
11.
plus 2, right?
Negative
minus 7.
Okay, minus 7, right?
Right,
So
right.
it definitely is
My
less
bad.
than, this definitely is less than the minus 13 over 3, right? Correct? So
Yes.
this is a new minimal now, okay? Is it the absolute minimum? No, not really, huh? But next week you'll learn how to find the absolute minimum.
Okay.
Absolute minimum is you can do differentiation again. Okay, so this is question 4. A little bit unusual. Okay, I think let's try to replace something you can do because I have, okay, no need lah. So wait for next week. So these are questions I intend to cover for you. All right, so yeah, any question you want me to do? Okay.
I think everything.
Okay, so question 4 I showed you already. So if you the rest up to you now. You can do this question until 12. Okay.
No, so we do question 2, 3, 5, 8. Question 2, 3, 5, 11, 12.
Yeah, at the moment I do this.
Okay, can.
The 8 only.
It's not question 2, it's question 3 only. Tutorial 2.
But then the just say what if you do question you do question 1 is like the same as question 2, but then we never do question 2. Oh.
Don't need do question 2, it's tutorial 2.
Okay, never mind, I do only.
Okay, so these are questions. Okay, so these are questions I do, right? Okay. So otherwise, you are free to do anything now. Okay. And
yeah, play game now.
So did anyone record the lesson? Anyone record the lesson?
I got lesson later.
I think you have record lesson. Afterward, I check whether you have record lesson or not. Okay, so then just mark attendance. No need mark attendance. Just go through the process of update. So CRS tutorial.
Victor, can you go through the quiz like today? Because like I don't know how to do some the
Okay, the quiz
yeah.
are today. Okay, fine.
Yes.
Let me go through some of them.
Yes.
Okay, the quiz like today. So there is in Blackboard. Okay, let me
Yes.
go to Blackboard. Okay, so let me choose the learning resource, the one you have just now, right? Quiz Center.
Yes.
Quiz Center. So let me share the screen with you. You're not afraid that I show your screen quiz, right? Or you want?
It's okay, Joe. Learning is for everyone.
Okay, so I can pick the one trouble. So okay, it's still different class, I think. Let me go back again. Make sure I got the same class. Smart Wheel. Okay, this is the correct class now. So we share the screen later on. Okay, so okay, I pick one student. Okay, I don't want to show the name. Let's see this question will do. Okay, we attempt.